Good morning, everybody. I'll let the last few people get their coffee here. We may have a few more people floating in through the morning. First of all, welcome. I think this is going to be an exciting, informative, and productive morning. Great topic. I want to welcome everybody who's here. As we're streaming this out to our faculty and staff that are out around the globe. Be safe out there. Also to CSU System, who is watching this right now. Excited to have you aboard, and of course all our industry partners. We started a month ago. We had an Ag Innovation Summit. One of the things that we talked about is this idea of ag tech, how to move forward in that. And we thought a perfectly natural way to start this would be with the concept of big data and how to ask a question around big data, how to start that conversation. And so for us this morning, having Bill Schmarzo be able to come in and talk to us. Bill is the Chief Technical Officer, Dell EMC Cloud Services Strategy. Big data. Okay. That's hardware, yeah. Big data strategy. Very excited to have him aboard. The plan for this morning, again, I've emailed it a couple of times, but he's going to be talking for the first hour or so, just talk about how to organize big data and how to characterize those questions, how to organize those questions. We'll have some Q&A towards the end. If you have a burning question, please feel free to raise your hand and ask it, but if you can, save it, write it down for later. For those of you who are out in the hinterlands on the streaming area, we sent out an email. There will be an email address to provide you a way to ask a question. Malia will take the question here and we'll be able to answer. So feel free to be part of this conversation. And then we're going to take a short break, and I want to try to keep it fairly short. Keep on time schedule. We got to get Bill on a plane at 2:30 so he can get out of here. But we'll go till noon. So we'll have a little workshop element. And he'll talk about that. We're going to gather kind of the Ogul Aquifer group and participate in that particular Megan Shapansky's research. And then once we finish with that, we'll have a wrap up. So without any further ado, and to keep us moving along, Bill Schmarzo.
Thanks, Ed. Wow. Two feedlots, not more than 20 miles apart, have a very different fatality rate among its cattle. A farmer trying to figure out what crops to plant, when to plant them, how much fertilizer, how much herbicides, how much water, when to harvest. An autonomous tractor trying to figure out what it does next. What do these things all have in common? An aquifer that stretches across the western plains, whose water is rapidly declining. What do all these things have in common? Data. They got a lot of data. There's a lot of data there. And the challenge that we see with organizations is that they got a lot of data, but they don't know what to do with it. They haven't done a very good job of framing the conversation, of really putting the right sort of perspective on what we're trying to accomplish. And I'll tell you right now, if you have an organization that wants to be data-driven, walk out the door. I don't care about data. I care about the insights from the data. I can't act on the data. It's the insights in the data. And what we're going to talk about today is a way to frame that conversation. Yeah, data's got a very important role. In fact, data is really critical. But you can't stop at the data. It's the insights and how we're going to tease out insights and how we're going to frame the insights conversation that allows us to turn the data from a conversation piece into something that is actionable. If we can't act on it, why bother? So I'm going to start by this frame right here. That is, organizations do not need a big data strategy. Part of my role at Dell EMC as the CTO of our big data consulting practice is I get a chance to spend all of my time talking to customers about big data. And to a T, they all want to start with, let's create a big data strategy. I'm like, what does that mean? What does that mean you're going to create a big data strategy? Instead of creating a big data strategy, let's talk about a business strategy. Let's talk about an operational strategy that incorporates big data. Let's flip the conversation. I don't want to talk about technology. Yeah, technology's key. I don't want to talk about data. Yeah, data's key. But I want to get insights that I can act on, that I can monetize, I can drive value from. And so today we're going to talk about this. We're going to talk about some approaches, some methodologies, things that we are teaching our clients to do. Also, in my spare time, I teach at the University of San Francisco. I teach at the School of Management, where I'm an executive fellow. We are trying to teach our business students to embrace analytics as a business discipline, to think like a data scientist, to embrace the concepts of fail fast, learn faster. And that's going to be my challenge today for everybody here. I'm going to challenge you to think like a data scientist. I'm going to challenge you to embrace the power of failure. You learn through failure. And we're going to reposition this conversation to make sure at the end of the day, what we're doing is actionable. If we can't act on it, why bother? Oh, and I heard, by the way, that Colorado State knows nothing about social media. So if you want a Twitter out there, put stuff out there. Let's create a show within a show. Let the world know that we are talking leading edge stuff here. The rest of the world can sit and be disappointed that they're not here with us today. So let's talk about it. Let's start this whole day off by framing 5 questions. 5 questions. 5 questions that organizations need to consider as they think about trying to transform their business using all this data and analytics and all these wonderful machine learning and artificial intelligence and reinforcement learning techniques out there. So question number 1. How effective is your organization at leveraging data and analytics to power your business models? Ultimately, data and analytics allow me to change my business. They allow me to understand so much more about my customers, my products, my services, my operations, that I can change the very fabric of my business and how I engage with my markets. We're going to talk about that question. Question number 2. Do you understand what the organization is trying to accomplish? Do you know what's important to the business of the organization? We're going to talk about later on today optimizing water consumption and the aquifer, right? We're going to talk about that. Do you understand what's important to your organization, and can you identify and understand and envision how it might benefit from big data and analytics? If you don't know what's important to the business, you're not going to get any place important. You've got to start. Stephen Covey said it many years ago. Begin with an end in mind. It's as simple as that. Question number 3. Stakeholders. Business stakeholders, constituents. If you're trying to impact the life of a farmer, by golly, they better be involved in the process. And I don't mean that they are, somebody you check in with every now and then, but they're not only on the boat, they're in the front of the boat saying, we're going this way. This is a problem I'm trying to solve. Getting business and stakeholder buy-in is critical to success. And we're going to talk about how we can leverage their expertise to help ensure that we're delivering the right solutions. Number 4, my favorite topic. We just finished a research project at USF about the economic value of data. And the research project to me was shattering. A lot of concepts, a lot of ideas that I had held as sacred were shattered as we did this research project. And by the way, that's one thing I'm going to challenge you with. When you start thinking about data and analytics and how to drive the value, how to monetize this, the biggest challenge that I have personally faced is the process to unlearn. Unlearning is hard. I grew up in the data warehouse BI space. I got started in the 1980s with Procter & Gamble and worked on a project with Walmart that really launched the data warehouse marketplace. I spent 20-some years in that space, wed to how BI and data warehouse people thought. And then I was recruited out of Business Objects by Yahoo. And everything that I thought I knew, everything that I thought was written in gold, chiseled on stone, was wrong. Be prepared to unlearn. When you're climbing a ladder, if you want to climb the ladder at some point in time, you got to let go of that rung below you. So be prepared to unlearn throughout this entire process, not just today, but throughout the entire process. And finally, how do we create a platform that allows us to drive collaborative value creation? How do I leverage the data, the analytics, my business constituents, the business model? How do I drive it all together? So that I'm creating something that's driving value to all participants, to all the stakeholders. Let's go to the screen. So we're going to do something here. Let's attack that first question, which is how effective is your organization at leveraging data and analytics to power the business models? And most organizations, by the way, when they're asked that question, have no idea how to respond. They don't even, there's no frame for that conversation. They don't know what good is. Right? What does good look like? And so what we did is we created, hopefully this shows up well, we call this the big, good, data business model maturity index. Good, staying on the board. Business model maturity index. How effective is your organization at leveraging data and analytics to power your business models? And what we found is that organizations tend to sit along one of 5 points on this maturity model. And the vast majority of organizations I talk to, now you understand, I spend my life in an airplane. I talk to a lot of customers, a lot of companies, a lot of industries. You can pick an industry and I've talked to somebody in that industry. Right? A lot recently in ag. Maybe it's because I'm from Iowa, right? Maybe it helps. But no matter who I talk to, no matter literally how mature these organizations appear to be, most organizations are stuck in phase 1, which is they're using data and analytics to monitor the business. They're using data and analytics to tell them what happened. And they think that's success. Reports and dashboards that tell you what happened. Now, great foundation. Without historical perspective, without that data, any new data that comes in is noise. So you have to have a good solid foundation of what happened. The problem is there's a chasm here. I spent 20-some years in this space trying to cross this chasm from a BI and data warehouse perspective. I could never crack. I was the vice president of analytic applications at Business Objects, the biggest BI vendor out there. The vice president of analytic apps, and there was nothing analytical about the apps I was developing. They didn't predict, they didn't prescribe, they didn't learn, they didn't adapt. Now what happened 5, 7, 10 years ago is that one thing happened to change this entire conversation. It actually is one word, the single most important word, I believe, in the whole big data conversation. That one word, by the way, is not Hadoop. That one word is economics. This is an economics play. From a technology perspective, it's 50 to 100x cheaper to store, manage, and analyze data than it was using traditional data warehouse and BI technologies. 100x. I'm not talking, organizations struggle by thinking, oh, faster, cheaper, smaller. No, 100x means think differently. It's a think differently moment. This is an unlearn moment. You have learned previously that data and analytics was really expensive, so I looked to minimize my data because data was a cost to be avoided. And today now we're looking at data as an asset. I want to amass it because I can exploit it. This is a think differently moment. And what's happening is that organizations are learning how to think differently about how they're applying data and analytics to their organization's key business processes. Great place to start. These are the things that your organization needs to do to perfection to be successful. Think about a farmer. Key process. What do I plant? When do I plant it? When do I fertilize? What herbicides, right? Think about all the business processes, the decisions they have to make and how data and analytics can help them. In particular, what we want to do is we want to leverage data and analytics to help them become more predictive. We want to cross this chasm into phase 2, which is what we call the insights phase, which is I'm leveraging this vast amount of data that I've got, right? Data from operations, data from drones flying overhead telling me the composition of my soil, data being captured by the John Deere machines with their little sensors in the ground, right? Weather data, the price of corn, research grants. The number of data sources out there is almost infinite. And there's a huge number of them publicly available. Huge amount of data out there publicly available. So how can I leverage all that data and all these different advanced analytic techniques to find things in the data that might be interesting? Might. The single most important word that I'm going to give you today is the word might. Embrace the power of might. You're going to find things in the data that might be relevant, that might be interesting, that might be significant. Most of the things you find in the data do not or are not interesting. But there's things out there that might be gold. And what we do is we find things in the data, we're looking for things that are unusual. We're looking for unusual patterns. Why do certain cattle behave certain way? Why do certain, God, you've probably all seen this, right? There are certain corners in towns where people will build a restaurant and a restaurant never sticks. That corner in town just churns restaurants. It just doesn't work. What's wrong with that corner, right? How do I find things that are unusual, and how do I learn about these things that are unusual? Because if I can find things that are unusual, I can start to predict. We want to become predictive. We're going to do a little exercise in this. I want to take the kinds of questions that I've been typically asking about what happened, right? What was my yield last year on this particular acreage for this particular crop? And now I want to predict. What do I think the yield is going to be next year? Right? We're going to talk about that. How do I create this predictive mindset? How do I start thinking like a data scientist? But ultimately what I want to do is I actually want to, if I can quantify cause and effect through predictions, ultimately I want to move to phase 3, which is the optimization phase. And I want to leverage prescriptive analytics. Right? Think recommendations. What I'm trying to do here, I'm trying to augment human decision making with data and insights. I'm trying to deliver recommendations as far as what crops to plant, what cattle, which of my livestock might need. I can leverage the ability to predict and quantify to prescribe. Let me give you an example. I did a project for a hospital in Denver. And the nurses there knew that whenever the Denver Broncos had a home game, that the 2 hospitals that were within a 2-mile radius of the stadium had an increase in broken bones, lacerations, and head injuries. Right? Whenever the Broncos had a home game, those hospitals in the emergency room had an increase in broken bones, lacerations, and head injuries. They knew it. What they didn't know was it was 37%. If I can quantify it, I can act on it. If it's 37%, I need 2 more nurses, 1 more doctor, and 1 more supplies. If you can't quantify, you can't act. Predictions are about quantifying cause and effect. If I can quantify, then I can prescribe actions. Ultimately, what's going to happen as you go through this process, you start at each of your key business processes trying to become more predictive, more prescriptive. What's going to happen, something that I think is really interesting, is out of this process, you're going to start gathering all kinds of learnings at the level of the individual. This is a very important concept, the level of the individual. So, I'm going to learn about, if you're in the business to consumer space, you're in the retail space or the hospitality or gaming, right? I can build very detailed behavioral profiles on each of my customers. What their propensities and inclinations and tendencies and associations, relationships. I can build very, very detailed learnings about them. What they're most likely to want to buy next, who's likely to commit fraud, who's likely to leave. I can build very, very detailed profiles at the level of the individual. But it isn't just humans, right? I can do it for tractors. I can do it for wind turbines and jet engines. I can use it for cattle. I can do it for acreage. I can build very, very detailed profiles because I'm learning more and more about these key individuals, these key, we're going to call these business entities. And as I learn more and more about them, it allows me to move to stage 4, which is the monetization phase. Now, you don't monetize data. People think, oh, monetize, I'm going to sell my data. No, no. The data is not what's valuable. It's the insights in the data. It's the insights about your customers, your stakeholders, your tractors, your wind turbines, your cars, your jet engines, right? I can use those insights to identify unmet needs, white spaces in the market, new products, new services, new pricing, new audiences, new targets. I can create new revenue opportunities by leveraging the insights I'm building at the level of every individual. We're going to talk about that in a little bit more detail as well. The power of one is critical here. Big data is not about big. Big data is about one. Finally, stage 5, the metamorphosis phase. I can never spell, so I just scribble it out. I claim my professorship there, and I just scribble it. Metamorphosis, though, is where organizations are transforming their very heart of their business. How they hire, how they reward, how they pay. Data and analytics in many organizations becomes the business. And in some cases, we're seeing organizations actually change what they're reporting to Wall Street because of the data and analytics they've uncovered. It's the whole transformation, the whole digital transformation at the end here. So this is what organizations can do. Sorry for the scribbling. There'll be you will get a copy of the deck. There's actually a cleaner version in the deck. Basically, this is what organizations are trying to do. Most of them are here, but you've got the foundation. This is not a hard process. This is not like trying to walk on the sun, right? We can do this. It just takes a process that's very much focused on the business problem we're going after. And in fact, let's talk about how you do it. If this is the what organizations can do, how do you approach this then? How do I move up this maturity model so that I'm really exploiting the value of my data and my analytics? More drawing. If you want to be relevant to the business, the best place to start is with the business. Let's start with a business initiative. We're going to talk later on today about optimizing water usage. But there are tons of business initiatives you can go after. In fact, organizations don't fail because of lack of opportunities. They fail because they have too many opportunities. And so you have to pick and focus. And so we're going to pick and focus later on today on picking off one. And the process we're going to go through is to understand for that key business initiative. So we're talking about optimize water usage for the aquifer, right? We want to identify the key stakeholders who either impact or are impacted by that initiative. And then what we want to capture, the key to the entire day, is we want to capture from those stakeholders with respect to the problem they're going after, the decisions they are trying to make. Decisions is the linkage point that drives everything together. Organizationally, when I think about determining the economic value of data, you're going to see that use cases and decisions become critical. It's the decision they're trying to make. And the beauty of decisions, the beauty of focusing on decisions is, first off, your stakeholders understand what decisions they are trying to make. They've been doing it for decades. They understand. You talk to a farmer, you talk to a marketer, you talk to a doctor, you talk to a teacher. You pick whatever profession or business or function you want to go after. They know the decisions they're trying to make. Teachers, for example, in a project we worked on, trying to figure out what kind of curriculum for what students. How do I group students in groups so I get the best group learning? What students need interventions? What students need to have tutoring, right? They're trying to make decisions, and the data that's out there to help them make the decisions, you can take your stakeholders who understand the decisions and marry them with the data scientists who understands how to optimize decisions. it's really paired analytics. Business stakeholders who understand the decisions, understand the environment, understand in what context try to make the decisions, and the data scientists with their big, huge, giant brains who know that there are 50 different types of neural network technologies. You know that? There are 50 different, you say, oh, I'm going to use a neural network. The data scientist says, which one? There's 50 of them, right? They know all that. I don't care. I don't care to know. They know. And when you bring those two parties together, that's where the magic happens. When you bring the data scientists and the business stakeholders together around the decisions is when the magic happens. You quantify cause and effect, you predict, you prescribe, you measure effectiveness. You learn, you adapt. The decisions. This is everything. If you remember nothing else about today, other than the fact that I'm from Iowa, understand the importance, the power of decisions. It is around decisions that we're going to drive everything. And ultimately, when you look at monetizing, and monetizing may not necessarily mean just money, it might be driving value, it is around decisions. How we optimize water usage is going to be driven around optimizing the decisions we make in support of that. Now, what we want to do is we want to take our business, our stakeholders through a process of identifying predictive questions. This is really the heart of the think like a data scientist process. It's easier to me to explain what we do than to actually try to describe. So I tell my students, I said, you've been hired by United Airlines, and you've been asked to forecast, to predict how many passengers are likely to fly from San Francisco to Paris next month. And then I say, what data might you need in order to make that forecast? And I break them off into small groups, and they go off and they get their little whiteboards and they're posting notes, and they go out and they brainstorm. What data might you need in order to make that forecast? And they come back 10 minutes later, and they present, and it almost always starts the same way. And they say, well, how many people flew last month? How many people flew the last 12 months? How many people flew the same month a year ago, same month 2 years ago, same month 3 years ago? How many people flew by route, by day, by time of day? Right? A lot of that transactional stuff, right? Good foundation stuff. And then there'll be this epiphany. The light bulbs will go off, and they'll say, well, has the exchange rate changed? How many weekends in the month? Are there any holidays in the month? Are there any special events going on in Paris? I was just in Paris 2 weeks ago. Are there any strikes planned? Because there's a strike planned, life in Paris sucks, right? So, right, how many Pinterest pins were there on Paris hotels? How many tweets were there about walking around Paris, right? There's all this data out there, and what happens is when you go through that process, you're going to uncover all kinds of other data sources that might be better predictors of performance. When you bring, the data scientist isn't going to think of these things. They're too busy trying to figure out which of the 50 neural network technologies to use. It's the business people who have the best ideas. Our teachers, we did this project, we were creating, they called Netflix for Teachers. They had the best idea of what data sources they wanted to go test. They came up with them, and the data science team tested them. Most of the data sources weren't effective. Most of them weren't better predictors of performance. Maybe 1 out of 50 was, though. But 1 out of 50 is gold. That's how you learn. You learn by failing and testing and trying and failing and trying again and failing and trying again until you do find those 2 or 3 or 4 data sources that are better predictors. Now you're ready to start talking about architecture and technology. If you were to come up to me, let's say on the street, like you would do any random person on the street and say, hey, random person, do I need to have Spark? I would go, I don't know. Do I need to have Kafka or Flink or Lyota? I don't know. I don't know what technology you need. But if I know what decisions we're trying to drive, what analytics we might need, what data we're going to need, how important those decisions are, which decisions are most important, which ones aren't, which data is most predictive, which one is. Now I can tell you what architecture I need. Now I can tell you what technology you're going to need. Right? I can tell you. But it doesn't start with the technology. And I would tell you about 99.999% of the companies I talk to all start with the technology. And then they wonder why it doesn't work. I installed it, I put a dupe in, I threw some data on there, I went and hired some data scientists, waited for magic to happen. And magic shit didn't happen. You get what you plan for. Put me back on presentation mode. Let's go back to the So let's talk about some really key concepts here that I want to make sure that we cover today. There are some key points that are fundamental to the data conversation. We're going to talk about a couple of them here. Some very fundamental things before we start getting into thinking like a data scientist. And so I call these slides kind of the amazing grasp of the obvious. Yeah, there's a bunch of data out there. Tons of it. More than you have ever imagined. I'm not just talking about social media. Research grants, patent filings, clinical studies. You want to do work on a smart building? I can find you data sets on smart buildings. It's unbelievable what data is out there. And more is being released. Cities and governments and universities like mad are releasing their data. Lots of data out there. Some of it actually might be useful. And we know that the IoT craze is going to create all kinds of even more data sets. Heck, I'm a walking beacon with my 3 little devices. We're not going to go into why I have 3. Maybe for beer we will. By the way, how many people here know what's after zettabytes? Yottabytes. Of course, right? Makes total sense. Yottabytes. So I'm guessing that after yottabytes, it's Darth Vader bytes. It only seems logical, right? So that just tells me there's a whole boatload of data out there. But more important than the data out there, more important than all this data that's out there for us, and the level of granularity of this data, is actually users' expectations have changed. And you can thank Netflix and Amazon and Spotify and eHarmony.com because they've learned to lead with recommendations. Right? Users are expecting that. Working with a bank right now. They're creating a score for each of their customers, a retirement readiness score. And they want to leverage that score to deliver recommendations to all their cardholders in order to figure out investments, spending patterns, right? All the decisions they're making financially. They don't want their institutions, customers don't want their financial institutions to hold their data. They want them to deliver recommendations to help them achieve their goals. So what happens when you see this kind of change taking place? I mentioned earlier that big data is not about big, it's about small. Organizations are being forced, in order to deliver the kinds of insights required to deliver recommendations to Bill Schmarzo about what he should be investing in, how much he should save in order to retire at some time in his life, you have to build very detailed profiles about me, about you, about your propensities, your behaviors, your tendencies, your inclinations, your patterns, your associations, your affiliates. You got to know as much as possible. Big data is not about big. It's about getting down and learning about you and you. If I get to that level, then I can start servicing you. If I don't have that level of detail about what makes you tick, what you're trying to do, what your behaviors are, then everything I'm sending at you is for my benefit and hopefully maybe by prayer be for your benefit. That world is changing, right? Because we can do this today. And it isn't, by the way, just humans, right? The cattle feedlot. Right? You can build very detailed profiles. You put an RFID chip on every one of your cattle. You can identify where they go, how much they eat. Right? You can learn so much about them. And you can create insights and scores about their health, about their production and performance, when they might die. And of course, other entities as well. This concept of individual, the power of one, is what makes this big data conversation so enlightening and challenging. You have a chance to service your stakeholders like they've never been serviced before. But I'll warn you right now, the minute you start using that data against them, they will turn on you. Just ask John Deere. Right? You have to take care of your customers. It is the ultimate customer golden rule. Take care of your customers first and foremost. Do everything for their benefit. And they'll reward you by giving you even more data and more loyalty. So when we talk big data, don't tell me, is my data big enough? I'm going to challenge you, is your audience small enough? Let's talk about data science. This is one of the most, so while I think the term big data is a lousy term, by the way, I think it's a horrible term. Because I get in conversations with somebody who say, well, is my data big enough? It's not about how big your data is, right? It's not. In data science, it's the same thing. Most books, most analyst publications, most conferences you go to learn about data science, these books go on forever, 500, 700 pages. And when somebody says, so hey, Schmarzo, what book should I read? If I really want to learn about what data science is and what it can do, what book should I read? And I say, well, other than my book, of course, I say the book that I have all of my students read, that's required reading in my class, is Moneyball? Moneyball is a data science book? By the way, Moneyball the book, good for data science. Moneyball the movie, not so good. My wife went and saw Moneyball the movie, and I said, what'd you think? She goes, oh, Brad Pitt, he's so cute. I said, what about on-base percentage? On-base percentage, right? I love the book Moneyball because without talking about data science, they explain a lot of the basic concepts of data science. This idea of the power of one, understanding each and every player, what they can do, what they can't do, right? Sabermetrics was the ultimate in building out these power of one. And I love how they think about what data science is. Data science is about identifying those variables and metrics that might be better predictors of performance. Period. That's all it is. That's all it is. What are the variables and metrics that might be better predictors of performance? Now, I can leverage, structured machine learning to find known unknowns, and I can leverage unstructured machine learning to find unknown unknowns, right? But in the end, all I'm trying to figure out is what variables and metrics might be better predictors of performance. If you can embrace that, you have mastered data science. And now you're ready to move beyond understanding data science to actually start using data science. How many people here come from a data warehouse BI sort of perspective? You don't count. A couple of people. All right, I'm going to skip by this slide. The only reason why I'm going to show this slide, because this was how I was wired to think about data and analytics. When I started doing data warehouse and BI back in the 80s, and for 20-some years of my life, this is how I thought. Whenever I talked to a customer, I always started to build a schema. That's how my life started. When I was recruited to Yahoo, this is what my world looked like. Instead of starting with a schema, we started with a hypothesis, a decision, trying to make what ads to show what people at what time of day. Where do we place the ad? All right? And so we start with a hypothesis around a decision. We go out and grab all kinds of data that might be better predictors of performance. I drop it into a data lake. Data lakes are different than a data warehouse. This is the only technology aspect we're going to get into. Is the most important thing is I don't need to build a schema to drop data into a data lake. Schemas take time, sometimes weeks, sometimes months to build. If I have an environment where I'm trying to learn, fail fast and learn faster, I can't measure that in months. So I can drop the data as is. By the way, try putting a video feed into a data warehouse. Call me when you're done because I'll be dead. Right? We prepare the data because the data is always messy. Rule number one, data is always messy. Always messy. I don't care what somebody says, well, my data is clean. It's not. I have never seen a clean data source. It's always messy. And then I actually do build a schema because I got to have something I can do some analysis on. The difference between what I do in a BI data warehouse world, in a data warehouse world, I'm building star schemas, really heavily engineered star schemas, and God help me if somebody wants to add another data source because the schema just comes crumbling down. I build flat files here. Oh my gosh, that's horribly inefficient. You're wasting all kinds of space. You're wasting storage. And when somebody says to me, I say one thing, 100x. 100x. It's 100x cheaper, I don't care. The cost of storage is mouse nuts compared to the importance of time to make a decision. And flat file schemas I can build fast. I can throw another data set in there now. And then what I'm going to do is I'm going to visualize the data using tools like Tableau. How many people here know how to use Tableau? Okay, I'm a ggplot2 fan myself. So all we're trying to do here is these are not dashboards. I'm trying to figure out in the data which elements are moving together. Which ones are moving to correlations or opposite correlations, right? Where do I have collinearity? Where are the outliers? In a data warehouse, I wipe out outliers. In a data science world, I hug, cherish, monetize outliers. Some point in time, that big gianted brain data scientist is going to have to quantify cause and effect. You have to quantify cause and effect, and you have to measure goodness of fit. And the goodness of fit is never very good. And what you do is you fail enough times that goodness of fit and a quantified value gets to a point where you feel comfortable enough that you can believe it. It'll never, you're making predictions, it'll never be 100%. By its very nature, it can't be. So since it's never going to be 100%, it's a level of comfort that I get by failing enough times. I had a project where a data scientist, she was fairly junior, it wasn't her fault. She came to me and said, hey, Schmarzo, solve this problem in the third iteration. And without even looking at it, I said, I don't have confidence. That may be the right model, but go fail for me 20 more times to confirm that that's the right model. Fail. So this environment here is very much built on fail fast, learn faster. I need an environment that allows me to bring data in minutes, be able to test it out, do transformations, ramp up, maybe I need to have 100 nodes, whatever that means, right? So I can process a bunch of data and get rid of the 100 nodes. I've got to do things fast. The cost of the data is minuscule compared to the benefit of the timely decision. We're changing the economics of this conversation. So ultimately what we want to do is we want to transform these questions about what happened. Everybody who gets reports and dashboards knows that reports about what were revenues and profits last year, how much fertilizer I used last year, how much downtime did I have, right? These are questions that the farmers know. We want to transform it to this. What were revenues and profits last year? What will revenue and profits likely be next year? And what data might I need in order to make that prediction? Here, right? How much fertilizer did I use last planting season? How much fertilizer will I likely need next season? And what data might I need in order to make that prediction? You can take your stakeholders who are used to asking retrospective questions, and you can start teaching them to ask questions about the future, to predict and ultimately prescribe. If we can quantify, then I can tell them what plants to plant, when to plant them, how much. I can start to prescribe. This is a very logical process, and it's not, you will find it much easier than you give credit to your stakeholders to make this transition from this to this. If we don't overcomplicate it by trying to spend 3 weeks explaining what data science is. But now we know what data science is. Data science is about identifying those variables or metrics that might be better predictors of performance, period. That's all it is. Everybody can understand that. Let me walk you through a simple example of how this process works. How am I doing time-wise? Am I good? I think I am. In fact, I do want to show this. So I'm working with the city of San Jose on a smart city initiative. And one of our problems, right, start with a problem. How do you be relevant? Start with a problem. We want to basically decrease accidents, in particular fatal accidents. So we got to report all this detail, all this history about where accidents occur, how many occurred, the fatality, the severity of those accidents, right? So all I want to do now is go through a process with my stakeholders at the city of San Jose to predict where I'm likely to have accidents over the next 2 weeks. And by the way, and what data might I need to make that forecast? Weather data, event data, when the school's in session, right? Sunrise, sunset, some of these roads has a big impact. And if I can quantify cause and effect, I'm thinking confidence levels, then I actually can prescribe where to put. Where am I going to put the police to slow down traffic? Where am I going to prelocate ambulances and tow trucks? Process is not that hard. If you pair the stakeholders with the data scientists, you will see phenomenal results. Let me skip this. So the process looks like this. You brainstorm a whole bunch of data sources. You go through this, we call our envisioning exercise, where you go all through and you gather as much data as you can possibly find. I actually had to hide the names here because this is a real project we did. And then what you do is a data scientist takes these variables and they start testing different combinations, different transformations. They might do a logarithmic transformation here, they might do a different transformation. They try different combinations until they find the variables that actually do predict. That's all they do. Now they will likely, because they're paired with a stakeholder, review, check, brainstorm other data sources, get a feel for, is this accurate enough for you to make decisions on yet? What's the comfort level? But the process the data scientists go through, all you really need to know from the business side is that they're going to test lots of different things. And what they test might be influenced by what insights you share with them. Pairing together. So summarizing this section, business intelligence is about questions. The kinds of analysis we do in business intelligence, reports and dashboards is comparative. Data science is about behavioral. We're trying to gain behavioral insights because I'm trying to drive and optimize, not questions, decisions. Questions are informative, might be interesting, but questions in of their nature are not actionable. Decisions are actionable. I'm trying to make better decisions. Make sense? Data science, demystified. You all know what data science is. Don't be snowed or greened by someone who has a more complicated explanation. Smart. I'm going to kind of go through this section because I want to get to the next section. The only point I want to make here is that when people are trying to create smart entities, say you're trying to create a smart farm, for example, you're trying to help create a smart farm. And we're seeing smart cities, smart airports, smart schools. It's really smart is really around the sum of the decisions that are being made. Again, it's back to decisions. You think about a smart farm, for example, they're making decisions around crop planting and rotation and harvesting schedule and yield forecasting and livestock management. Right? They're trying to make a bunch of decisions. Smart is really nothing but a bunch of decisions. But you can't do them all at once. We're going to have to pick and choose and prioritize. And if we do it right, the results of one use case will feed the results of the second one. And we'll create an environment that allows us to learn as we start doing this. Again, it gets back to this concept of if you hear somebody start talking about smart, what is smart? Don't get all balled up in it's IoT, it's all these devices. It's really, we're trying to make better decisions around areas such as this. Don't overcomplicate this. So let's talk about what's really going on in the farming community. I've got some stuff. I was very fortunate because I've been working with some folks in this space. I got some good stuff to share. So kind of like in the previous slide I showed, that the farmers are trying to make decisions, right? This comes from the GrowMark folks. What types of seeds, what type of insurance do I need? Should I acquire or lease land? They're trying to make decisions. Data and analytics can help them make better decisions. We can help them optimize those decisions. But as you start thinking about analytics, there's some real simple rules to keep in mind. Number one, let's start with the most important decisions. Let's understand the decisions we're making. Let's prioritize those and put those together so we understand what decisions are most important and which ones aren't. If I'm going after, say I'm in the insurance space, and I'm trying to flag customers who might attrite, who might leave, right? I'm probably first going to create a score on all of my customers to flag those customers who are at risk of leaving and those who aren't. Give them a score. But before I start making actions on them, before I start sending them promotions or campaigns or contacting them, I might want to secondly build a score about how valuable that customer is to me, so that I'm not fighting hard to keep a customer who's not profitable. So think about the decisions, which ones are most important, and focus on those. Lead with recommendations. You don't want your farmers, you don't want your engineers, you don't want your teachers, you don't want your physicians to become data scientists. We don't need to. So in a case like optimizing weed control, I can tell the farmer, where to spray, how much to spray, when to spray it, what to spray, right? You can get down and lead with predictions or recommendations. You can tell them what to do. You don't need to turn the stakeholders into data scientists. They can benefit from the data science. Financials. Take this time to understand the financials. In the end, most use cases will be driven by the ability to deliver value. If I know that this particular optimizing stand establishment in the farming space is worth $9,000, gives me a basis point for making decisions, per acre, by the way. Right? So you start now, you got some value, and of course, have a use case roadmap. Understand how these use cases all play together. Which ones are dependencies on other ones? So you put in place the right process. Your first use case you go after may not be the most valuable one, but it sets the stage for every other use case. So think through your use cases and put together a roadmap and knowing what you're going to go after. Good, we're on time. By skipping a few things, we got back on schedule because I really want to talk about this. This is my favorite topic. And it became my favorite topic when I realized I was thinking about it all wrong. So we launched a research project at USF trying to understand if we could quantify the value of an organization's data. And it really was driven by a lot of conversations, a lot of press and conference presentations and talking about monetizing data. There was this infatuation with monetizing data. And I talked to a lot of customers and they say, we're trying to monetize our data. And I would say, what does that mean? What does that really mean? Are you really trying to sell your data? And so we started doing some research here. And before I go into in more detail here, a couple of aha moments. First off, everybody was trying to quantify the value of data based on accounting methods, right? And accounting tends to make its determination based on either what you can sell it for or what you paid for it, right? If you have an asset and if I know what I paid for it, then I can put a depreciation schedule against it. And I can start writing it off. So all the research was taken from an accounting perspective. But accounting is a very backward-looking approach. And we struggled with this concept until we came across, okay, this is really nerdy, I'm sorry, Adam Smith, Wealth of Nations, 1776. He talks about value creation. And everybody gets infatuated on the value creation. He talks about value in exchange, right? What's my data? What's my asset worth in exchange? But Adam Smith also talked about value in use. And that's what we glommed onto. That it wasn't what we paid to get the data that determined the value. Could we determine the value of the data based on how it was used? Could we flip the conversation? Instead of using an accounting technique, could we use a different approach that was more predictive as far as how we were going to use the data? And the thing that sealed it for us was a conversation about, wow, what does that all show up? Come on. There it is. Yeah. There's actually words, and Lord knows why the words are on top of each other. Maybe it's a conspiracy theory, but I can explain it. What happened to us, we started thinking about data as currency. And we started looking at other forms of currency, like money, right? Money's currency. And if you go to like a Starbucks and you give them $1, and give them $5 and they get a cup of coffee back, right? But once you give them the $5 is gone. And eventually this cup of coffee will be gone. Right? Same thing with humans. Humans is a form of currency, right? And I'm here presenting today. I'm not working with a client. I'm not writing a book or a blog. I'm not cleaning the garage, God help me, right? So money and humans, from a currency perspective, have a transactional limitation. I can only use them for one thing at a time. Data doesn't have that. It isn't like data wears out. It isn't like I use it up. I can use data over and over again. We said it had had a network effect. We were wrong. It's not really a network effect. It has an economic multiplier effect. Data, if you start applying economic concepts to data, we start to get a real feel for what the potential of data, the value of data in use is. Let me walk you through a really simple example. Point of sale data, right? Let's say my first use case I want to go after is I'm going to use my sales organization to improve promotional effectiveness by 2.5%. You can use this data set to help make promotional effectiveness improve by 2.5%. And that 2.5% has got some dollar value associated with it. Might be 10 million, might be 5 million, might be 20 million, I don't know what it is, right? But it's got value. Being able to improve promotional effectiveness by 2.5% is worth something. That same data set, by the way, can also be used by marketing to improve customer acquisition by 2%. And can be used by the call center to improve customer retention, and can be used by product development to improve new product introduction. What's interesting here is the same data set at zero marginal cost can be used across an almost endless number of use cases, all of which have some value attached to it. It may not be a lot, but I'm getting it for free. When you start thinking about the value and use approach, data has characteristics as an asset that we've not seen in anything else we have in our books. It never depletes, it never wears out, and I can use it across an infinite number of use cases at near zero marginal cost. Holy cow. Holy cow. Data's not the new oil. Data's the new sun. Right? It has this kind of potential like we've never seen before. And so what happens now is the problems associated with data, what we've seen for decades in the data warehouse space, start to really bear down when you start to calculate the value, economic value of data. For example, data silos and shadow IT are the great destroyers of the economic value of data. If you have organizations that won't share data because the value of the data comes when you can share it across use cases, if you can't share the data, you don't get the value from it. And in fact, if you don't share a holistic view of the data, not only do you not get value from it, but you might make the wrong decisions. Let me give you an example. A project we're doing for a financial services institute. Dramatic effect. They're trying to create a score on every one of their customers and how valuable that customer might be. Credit cards, checking, savings, mortgage, car loans, student loans. The personal wealth and the small business organizations won't share their data. So I have all this data except the personal wealth or the private wealth and the small business group won't share their data. That means that I'm creating calculations on customers that might be inaccurate. Right? There may be a customer whose credit card usage patterns indicate that they're a risk to me, who actually might be in a small, medium business with a dramatically growing business, who I may just cut off. So if you have data silos, if you don't share data across the colleges about your students, you risk making the wrong decisions about how to help them be successful. I have 3 kids. My 2 oldest boys went to private schools and graduated in 4 years. I was devastated to learn that at public school, the conversation is how do we improve our 6-year graduation rate? I said, wait a second. You're talking about graduate school in 6 years? No, undergrad in 6 years. I said, are you kidding me? You're focused on 6-year graduation? It should be 4. When did we give up? When did we give up so easily? Right? if you don't have a holistic view of your students, as an example, how do you best serve them? How do you get them the kind of education they deserve in the time frame they deserve to have it done in? Sorry, but shame on universities for accepting and settling for 6 years. My daughter's going to public school. I told her, she's got a certain block of money. I said, you graduate in 4 years, you're going to have money for grad school. You graduate in 6, you have no money left. Work hard, honey. The other thing we saw too, this surprised us. Orphaned analytics. Organizations that were very senior, very mature in the analytics space were building analytics to solve one-off problems and never operationalizing them. They would get a Krispy Kreme sugar rush high from solving this one problem and never reuse the analytics. They were orphaned, they were hitting the floor. And we're thinking about how do we solve that problem? Because analytics have got value, but we're not getting value from it. So what we did is we took as you probably would guess, we found that as part of our research that the use cases become the linchpin that holds together how I identify and prioritize and use my data, and how I identify, prioritize, and use my analytics. It's the use cases that brings the Rubik's Cube together. The use cases or the decisions, right? No surprise here. We've talked about this. Start with the use cases. Let me walk through an example of how this works. So my students, we do a class. We pick Chipotle. I like Chipotle. So we pick Chipotle. We take publicly available data. We go through a process. We focus in on how do we increase same-store sales by 7.1%. We calculate it's roughly worth about $191 million a year to Chipotle to solve that problem. We go through a process of brainstorming the decisions. We're going to do some of this today in our workshop. We're going to brainstorm decisions that the different stakeholders make, and then we group those decisions into use cases. You know, we can increase same-store sales by increasing shopping bag revenue or improving promotional effectiveness or local event marketing, right? There are ways to do this. We prioritize those use cases based on business value and feasibility. This is actually probably the single most important tool I have as a consultant for driving organizational alignment, is get people together and figure out the business value of each of these use cases and implementation feasibility over the next 12 months. If you don't give it a hard frame, feasibility always becomes easy to do. If you say 12 months, you find some things like the infamous Project F. Change the world, can't do it in 12 months. Impossible. You prioritize and then you start going after and building out your analytics. And in particular, your data lake. The foundation for how the organization is going to capture, reuse, and refine its data assets. So my first use case, I can increase store traffic through local events marketing, and my team calculated it's worth about $62 million a year. And to do that, I needed 5 data sources. Right? So I'd go out and gather 5 data sources, put in my data lake, data governance, security, privacy, traceability, lineage, all the things required to make data a real asset. 5 data sources to solve that problem. I target problems with financial value because I can get people in the business to help fund all the things needed to make certain that data is an asset. I don't just throw it in the data lake. It becomes a data swamp and you do things like that. Index and catalog, all the important things. Second use case, through a customer loyalty program worth about $56 million a year. Need 5 data sources. Oh, but wait. 3 of them are already in the data lake. 3 of them cost me $0 to use. I only need to pay to acquire 2 new data sources. And you can start seeing what happens here, use case by use case. Each use case has value. Each use case needs data, but some of the data starts to get reused across use cases. And so what happens, even though maybe the value of these use cases starts to drop off, the cost, because I'm reusing data, starts to approach 0. If you do an ROI calculation and your denominator starts approaching 0, you don't need to be a math major to know what happens to your ROI. When your denominator starts approaching 0. So what happens is you start seeing what data sources pretty quickly are most valuable to you. Look at point of sale data in this example. It's used in 6 of the 7 use cases. High value. High value. So now I have the basis point for making some attribution of the value back to the data sets. And we won't go into details about it, but we can get down to the point of predicting the variable predictability to say which of these data sources actually are most important. These 5 in combination give me the most, but this one actually accounts for 55% of all the variability. That gets 55% of the weight. I'm going to give that 55% of the value. And now I have a mechanism for attributing value back to the data. Simple. It's a simple process. Start with the business, start with the decisions, brainstorm what data might be useful, have the data scientists tell you which ones are, put it in the data lake, support it. Don't just dump it in there, but all the data management services that really makes this becomes a whole different conversation. But now, data made sense, data worked, it was easy. Where we struggled was on the analytics. And this was my fault. I had this conception, and I'd actually written about it, that data is curated, or the analytics is curated data. Analytics is curated data, so it should behave like data, right? Wrong. Analytics isn't like data. Analytics is actually like software. So what happened is we built these analytic profiles at the level of the individual. So every individual has an analytic profile, and we create scores. Right? We create scores, and we put them into this analytic profile so I can reuse the analytic results across an infinite number of use cases. So my first use case, improve campaign effectiveness. I need to build demographic and behavioral segments on each of my customers. Demographic based on age, education, all that other crap that isn't really very predictive. Behavioral, very predictive. How often do they come? When's the last time they were here? What's their frequency, right? How much do they spend? Who do they bring with them? What do they buy, right? So you can start building very detailed behavioral profiles and segments for each of your customers. Second use case. You need to build a customer loyalty score. Watch what happens here. Watch the screen. To build a customer loyalty score, I had to improve my behavioral segments. I brought in other data, and I improved my behavioral segments. I needed an improved behavioral segment in order to really understand and assign a score, a loyalty score. So I checked out behavioral segment 1.0. I modified it, came up with 1.1. The use case that benefits from the improvement in the behavioral segments from 1.0 to 1.1, the use case that benefits at zero cost is this use case. My campaigns just got better. Now maybe 0.1% better, but I got it for free. 0.1% better over zero is a nice ROI. And so you can start seeing what happens as I start treating the analytics like software. So think about check-in, check-out, version control, regression testing. You're using things like Jupyter Notebooks and GitHub, and all of a sudden your analytics starts to sit inside this key value. This is nothing but a key value store. That's all it is. And I've got the analytics now. I can index, I can catalog, I can put security. Everything I do with my data, I can now do with my analytics. I can now start sharing analytics. In fact, our next research project, which we're going to struggle with, I know, is in our heart, we believe that while data has value, we think the analytics probably has 10x the value. If I know somebody's loyalty score, it's a lot more valuable than all the data that comprises it. I don't know how to price that yet, how to value it, but we're going to figure it out. And so what happens now is your data lake takes on a whole new existence. We're not talking about data lake 1.0 where you throw a bunch of technology out there. I'm not even talking about data lake 2.0 where you're building an elastic environment. I'm talking about data lake 3.0 that's actually driving your digital transformation, that's changing the way you do business. It's taking the data and the analytics that are your assets of the organization and allow you to capitalize and reuse those across new use cases you haven't even thought about yet. But it prepares you to move in all kinds of new directions. Skip. I'm getting the hee-ho. So we talked about this chart. See how much cleaner that is than my drawing? You'll get a nice clean chart. There are technologies that are going to allow me to move up. Starting with predictive analytics. I like to think about predictive analytics as quantifying cause and effect. That's all I'm trying to do. I'm trying to quantify. 37% increase. I can act on that. I'm trying to deliver recommendations to optimize human decision making. He has a bunch of different technology for doing that. That's interesting, but don't get fixated on it. But eventually I want to put in place an environment that's continuously learning, not replacing the humans, making the humans more effective. How do I make the teachers, the nurses, the engineers, the clerks, the tellers, the fund managers, how do I make them more effective? How do I put in place an environment that allows the environment to continuously learn? That's where we want to go. It's not complicated. Yeah, these things in the brackets here can be complicated, and it might be worthwhile to spend some time reading about what they do, but don't worry about becoming a machine. Don't worry about learning how to code an unsupervised machine learning algorithm versus a supervised machine algorithm. Doesn't matter. Just know what it can do. So we have time for Q&A, is that correct? Excuse me.
Yes, we have a few minutes if we have questions from the audience. I know we have some questions from our colleagues down at CSU Pueblo, but if you have any questions, I can pass the microphone to you so we can make sure we capture that also on the video. So any questions initially here? Malia, you want to go ahead?
My first question from someone online is, how does John Deere's experience show that supporting your customers builds loyalty and increased business?
The John Deere story is very interesting because John Deere started off with really trying to help the farmers be more effective. But they did something that crossed the line, which is the data. There's a big debate about who owns the data. If a John Deere tractor is going through your farm and capturing, doing some farm, who owns the data? Is it John Deere's data? Is it the farmer's data? And so there's a very big battle looming across a number of different, we're seeing this in the NFL and NBA now too, about player performance data. Who owns the data? And so what you're going to see, I think John Deere's efforts initially were very noble, but they got in the way of the golden rule. Always do what's best for the customer. And instead they were looking at what was sometimes best for them. And in fact, there's even an issue now that they lock out the farmers from making any changes to the tractor. Right? So you have farmers in Nebraska who have learned how to hack a John Deere tractor so they can make adjustments and fixes in the field and not wait for a John Deere certified technician to get out and fix it when they're basically farmers operate in very tight windows, right? Most of the time, maybe most of the time it's not really chaotic, but when they're planting and when they're harvesting, it's chaotic. And they can't afford to have a breakdown. They certainly can't afford to wait a day or two to have a John Deere certified mechanic come out and fix it when, by the way, they can fix it themselves. So I think watch what's going on in the John Deere Monsanto space, watch what's going on in the NBA and the NFL about who owns the data. Because ultimately I think it's going to boil down to, even the Equifax thing that just happened. Right? All of our data got exposed. All the data that we didn't, I'm sure, thought we consent to give out, but when we checked the little box of the 600-page thing for Facebook that said we're going to give our data to anybody who wants it, right? We're starting to see this backlash about who owns the data.
Thanks. Could you talk about the security privacy consequences of collecting Darth Vader bytes of Internet of Things data?
I wasn't going to answer that question until they said Darth Vader bytes. So I think that's great. Technology is always ahead of the law and rules and regulations. I think privacy, what happened at Equifax, is one of those kind of things that's going to alert people to what's going on. Deep down inside, maybe we know that every email we send, every click we click on, every post we post on social media, every time we walk by the entrance to a Walmart, people know about us. We're kind of blissfully ignorant, and we shouldn't be. I think organizations, as you start, the governments are starting to act. I don't know if you know about Europe has this law called the GDPR. And if you are making decisions on analytics that has impact on a person, like denying them credit, like a Fair Credit Reporting Act, the customer has the right to see the analytics that denied them the credit. And so if your analytics can't get down and say you were denied because you missed this number of payments or we think you're a risk here, those companies can be a substantial fine for those. So it's going to get messy, and it's going to get really messy before we get any sort of clarity. And it's going to have to be up to the businesses because, again, I think the legal system, and in particular our government today, can't do anything. So I think companies are going to have to be best served by really embracing the golden rule, which is take care of your customers first and foremost. If you're working against them, it's eventually going to work against you.
How do you balance The competing pressures between shareholders and customers then, because that seems to be like there's different motivations in serving those constituencies.
Yeah, I think that's the heart of the question, right? That's the heart of the challenge. It's a cultural challenge because you have organizations that have to make a profit to live. They have shareholders who demand profits. We've just, through this little work we've done here, we see there's a lot of value in the data we have. And so there could be a real onslaught of organizations feeling pressure to get more value out of their data, to take advantage of what they know about customers. But let me, I know we're going to run out of time, so my last point, and then we'll take a break. One thing to think about, just because you know something about someone doesn't necessarily give you the right to act on that. We call this decision governance, and we think that what's going to happen eventually, and this hasn't happened nearly as fast as I had hoped it happened, is that organizations, the same way they have data governance, they're going to have to embrace decision governance, which is what decisions am I willing to make about what I know about my customers, and what decisions am I not going to make. The Target example of, I think we probably all heard the Target example of the underage girl who Target sent a bunch of prenatal stuff to. The father went ballistic because the Target was sending them her stuff, and the father finds out 2 weeks later that she's actually is pregnant. Target data science team thought that was a huge success. Target PR thought it was a disaster. Without governance in place, you allow people in the organization, maybe at levels you don't really think about, to make decisions that could carry all kinds of severe consequences. 10-minute break?
Yes, we'll go ahead and take 10-minute break. We're at 10:20 now, so about 5 minutes late, but we started 5 minutes late, and that'll get us there on time. And so what we're going to do is we're going to actually move a couple of these tables out of the way. The people who are in the Ogula Aquifer research group themselves will have you sitting down here in front. Go ahead.
A little workshop, and because with this larger audience, we really can't do a workshop very effectively. We're going to take a small subsegment of about 10, 12 people. We're going to do the workshop here, and we encourage those who want to stay to watch how the workshop process works. Is that fair?
Yeah, and I think you said maybe they can actually, if they have ideas.
If you have ideas and want to
please-
contribute, please do.
Please do as part of that. That's what
Yeah.
that is. And we'll do that workshop. We'll continue, and then we'll have a wrap up towards the end. For those of you who are streaming in, if you have some folks from your workshop, we do have a conference phone here that'll be part of that, and we have provided that dial-in number for them on this if they've been watching this on the stream. So 10 minutes?
Yep.
All right. Thank you very much. Okay, if you could come to your seats as quickly as possible. Enjoy your meal, but at the same time, we'd like to start the next activity here in a minute or two.
So there's a lot of people in the room who actually have a lot of valuable contributions here. So what we're going to do is we're going to take the core of 10 or 12 people, and they're going to be responsible for working with smaller groups of you around these 5 different things that are going to come up. So be prepared. You're going to be involved in this process. We're going to kind of, because we can't gather feedback from 60 people simultaneously, we're going to basically have assign 10 people to go work with everybody else and then bring back the results. So be prepared to work in small groups. Because it is Megan's day, you know. This is all about Megan.
Bill tells a story about finding data in unexpected places that I always love to hear about, the casino. And it was the car check, I think, that who found?
Yeah, the valets at a casino start to learn about people who come there a lot. And so what happens when somebody drives into the casino and the valet notices something different, like the person has a new car. We've now trained the valets to say, hey, you got a new car, what's up? And they might say, well, you know, my car came off lease and so I got a new one. So knowing that somebody leases car is a good thing to know. Or my car just literally wore out, the tires popped off, I had a new car, and they said, oh, that's cheapo, like Bill Schmarzo, right? Or they might say things like, yeah, I just retired, and I celebrated by buying a new car, oh, right? Or my youngest child just went to college, or just graduated college. I'm an empty nester. And so we capture these things because each of these little tidbits of data, when taken in combination, can give you a much fuller view of that person, right? Somebody who's all of a sudden, if I know sooner than the other casinos that you've retired, I can try like mad to make sure that I get all of your business. Or you're an empty nester, I get all of your business, right? So to be able to identify even little bits of data, sometimes it comes from the most unusual sources, which really, I think, points to what we're going to do today. So we're going to brainstorm today a lot of different ideas, and we're going to categorize it from some exercises. There's one rule in this room today. One rule. All ideas are worthy of consideration. All ideas are worthy, because you don't know which idea might be the game changer. So don't hold back. Don't say, well, that idea, I think that's kind of stupid. Who cares? Who cares? Maybe the stupid idea is the best idea. So in this room, the next hour, all ideas are worthy of consideration. So here's my core group. The problem we're going to go after is optimizing, is it Ogala aquifer water usage. And Megan, if I can put you on the spot to kind of give us a little bit of introduction on what's going on here, what's kind of causing the problem, what are the challenges?
Sure. So I guess quite a few folks in the room know, is this working? That the Ogallala Aquifer is a groundwater source that goes under 8 states across the Midwest. It is a huge source of water for irrigation in that region, and it's estimated that once you put the livestock together with crop production, about 30% of U.S. crop and livestock production is grown in this region of the U.S. Not all of it supported directly by aquifer water, but a large proportion of it is. And so it is declining, not everywhere. It's very heterogeneous, and so that's one of the challenges that our project was funded to address, is that there are all these doomsday, the sky is falling stories about the aquifer, but the reality is the context depends, the story depends where you are. Nebraska has a much deeper pool than Texas does, for example. So that's one piece. There's a lot of spatial variability. There's climate variability. And then on top of that, it's managed locally, mostly, by groundwater management districts in these different states. So as we look to the future and putting in the context of climate change as well as other forcing factors, how are communities going to evolve and adapt to, in some areas, declining groundwater, definitely changing climates, and what does that look like? And so I think our project is mostly tasked with that sort of predictive scenario, what if, to help identify emerging technologies, decision support tools, policies. So we're looking at social science, biophysical science, and crop management. So what can we do to help the stakeholders being producers, groundwater management folks, community members in these rural areas? What does the future look like for them, and how can we provide tools, science, resources, technologies to help them adapt to declining groundwater?
Any questions about the problem, the state of the problem? Okay, let's jump into the exercise. So we're going to actually follow this technique we talked about earlier. And we talked about the problem. How did it come to exist? What are or were the primary causes? I think we've covered some of that stuff. Anything else we might have, I think we understand the economic and potential environmental costs and benefits associated with this. I think it was interesting. I didn't realize that the problem, of course, isn't uniform. It makes total sense that Nebraska's in much better shape than places like Texas. So what do we want to do next? Is we want to make sure we identify who are all the stakeholders that either impact or are impacted by this initiative. And so if we can go through a process, if we don't mind working in small, again, we're going to break this exercise is probably the easiest one, but I want to make sure that we have a really good understanding of the ecosystem of people who are impacted by this initiative. So if you can go out and work in small groups, put one name per post-it note, and then we're going to come up here and make sure we've identified all the key stakeholders. Make sense? Got 5 minutes. You need to go out and pick a group to work with, pick some groups of 2 or 3 people, get together, start brainstorming. We may ask you to explain why a stakeholder's on there. So if you got a name, yeah, there we go. Thank you. Thank you. Thanks, Jay. And people online, are you going to email you what they've got for names? Are they going to? Okay. Do you have one person from your team who's going to present? Come up. Thanks for volunteering. All right, well, I'll tell you what, why don't we do this? If the ones that you have don't come up, volunteer them. Okay? All right, let's go ahead. Let's bring them back together. Let's see what we've got here. For those of you, if one of the names of somebody you thought was a stakeholder doesn't come up, please raise your hand and say, oh, what about blah, blah, blah? Yes, so why don't you start first and call them out as you lay them up there.
Okay. Local community members, growers or producers, municipalities, consumers, writ large, distributors, public land managers, local politicians, federal, state politicians, oil and gas industry, manufacturing industries, outdoor recreation users.
Okay, if you've got, we'll go next here. If you have anything that's different, or you think it's different, feel free to put them up here. Jay, you going to go? Thanks, Jay. All right, thank you.
Importers and exporters business, water rights holders, municipalities, students, landowners, end consumers, and let's see, growers, ranchers. Let's put ranchers here.
Yep, I thought consumers we had somewhere. Here we go. Good.
Yep. All right.
Good.
That's good.
Excellent. We got farmers and growers. Yep.
Okay, good. All right, so we have wildlife,
Very good, yeah.
ag lenders,
Ag lenders.
agricultural lenders, all farming related enterprises, so these aren't farmers, but anything that's attached to the ag space. Well, that kills a lot. Which, under that goes trucking companies who are affected by changes in what people are growing and shipping.
You can still keep yours if you have individual ones, it's okay.
Well drillers, drones, smart ag, and any related tech companies, and energy companies.
Wow, very good. Other contributions? All right.
We have groundwater districts, surface water managers, and we split the ag to ag input companies like seed and fertilizer companies, irrigation companies, crop insurance.
Oh, good. Very good. Isn't designed to be perfect, but I bet you we're probably within 90-some% pretty complete list here. This is great. So, by the way, this exercise does reward people who participate. So thank you for people who are keeping it involved because we got more of this coming up. So we're going to come back to this in a second. And what we're going to do is we're probably going to pick 2 or 3 of these people. We're going to deep dive on 2 or 3 of these stakeholders. But before that, another group exercise. This might take a little bit longer. I want you to think about the entities, the business entities, the nouns around which we would want to capture data and analytics. One entity would be, by the way, you're going to see some overlap between stakeholders, like a farmer is an entity, but also livestock, other things. So I don't want to give you anything more, but I want you to break back in your group and think about, these should be nouns. And these are the nouns around which we want to capture data and insights about, that we think they're going to be, that might be important to help us around optimizing water usage. So break into your groups, go through it. This will be a little bit more of a struggle. It's not quite as straightforward. Don't worry about being wrong here. If you've got an idea and I don't know if that's right, just write it down. I don't care. Okay? All ideas are worthy of consideration. So let's take another 5 minutes and go through this process. Build the analytics in order to optimize water usage. Let me clarify something. I got a very good question. So I got a question about fertilizer usage, fertilizer optimization. Do you want the variables, or what am I looking for there? So the phrase there that I'm looking for is the word fertilizer, because it's around the noun fertilizer that we want to do analysis to figure out fertilizer usage, fertilizer effectiveness. Right now we're just capturing the fertilizer, and we will later on come back to start thinking about what kind of analysis we want to do against that noun. Okay? Thank you for asking. That's a good example. Let's bring them up. There you go. That's smart. All right. Here we go. Let's talk about some of the key entities.
Okay, farm units,
Everybody listening, call them out.
weather, climate, small farm, we wrote the aquifer, crop yield curves, soil, insurance,
Wow.
seeds, water, surface and ground, economic value model, who's the ag income for? Ag small business, geology specifics, people, well production, tractors, bank loans, communication means, and I'm not sure if that fits. But
Like I said, all ideas.
list of info sources, like where people get their info.
Okay. Good. All right. If this may not be big data, but it sure is big stickies. Go ahead.
Alright, we had subsidies, human diets, urbanization, energy sector, sort of stakeholder, food waste, food processing, markets, farm agricultural economy, crops. Also had soil.
Yeah, we had soil.
Plants, livestock, human health, water. We had weather too.
Good, thanks.
Climate, water rights, wildlife, habitat, farm machinery with tractors, irrigation equipment, irrigation wells or pumps, population, farm workers, trade, rural economy, grain elevators, sort of distribution infrastructure.
So like Megan takes up the entire sheet.
All right, I'm trying to kind of, I took out the ones that have already mentioned.
Okay, thanks. This is great, though. This is what it's all about, right? This is called diverge, and then we're going to converge, right? Capture all the ideas first.
Should I just like stick them on the legs?
Yeah, just keep kind of do the best you can.
Okay, so we've got real estate sales and land value, farm level groundwater use, water quality, the number of consultants and businesses,
It's like a research paper.
population density information, consumptive water use, data on application efficiency, data on non-ag, municipal and industrial use.
We'll put it on the second page here so we don't lose them.
Fast internet availability, interstate relationships and contracts, market data and futures data, recharge methods, precision ag use and adoption rates, yields, water table elevation monitoring, and consumer preferences.
We don't have much left here. We sort of have a section on recreational, like hunters, fishermen, campers, hikers.
Okay.
We thought the recharge rate, I heard that mentioned, that's really crucial. Then we have some stuff on fertilizer and pipelines.
Very good. Policy? Nope. That's a. All right, good. All right. lot of entities. So here's what we're going to do next. And Megan, I'm going to need your help here. The next step we want to do is we want to, this part starts to get a little crazy. So in order to keep it from being totally unbounded, what we're going to do is we're going to pick two stakeholders, and we're going to pick two or three entities, and we're going to brainstorm the decisions that stakeholder has to make around that entity. So, for example, I've already picked growers. That's one stakeholder I really want to go after. I would also like to go after oil and gas. I think there's something interesting there. And maybe one more, I'm not sure, between municipalities or land managers or water right holders. Which of these three, Megan, I'm going to make you make a choice?
I was saying municipalities probably.
Okay.
Well, I mean, I think it could be the managers I would change to groundwater district managers
Okay. So we'll do 4 then.
rather than public land managers.
Okay. So we're going to have those 4 entities, and we want to look at them with respect to those are stakeholders, which entities we want to go after. Obviously, I'm going to pick crops and water usage, that's kind of the theme here. Are there other, I kind of highlighted soil, but are there other entities around which we would like to do some analysis that pertains, that you think most relevant to optimizing water usage? All right, weather.
Sorry, what were the ones you chose already?
Soil, crops, farm ground usage, and weather. Did you want to add one more, or is that? All right, futures.
Market, some measure.
Okay, it's up here, right?
It's on the next page.
I'm going to move it to the front here then, so I. Where is it? There it is. Okay. 1, 2, 3. 5 is too many. Which one should we drop out of there? I'm going to drop soil. No, okay, leaving soil in. Megan, you pick. Why am I making this choice? You're the expert. I don't know this stuff. We like futures. Well, this is all about water usage. Maybe that one.
Drop soil, that's fine, because I know that I'll maintain it.
Well, it's really leave it on there because we'll drop this one because it's all about water usage. This is kind of a duplicate. So we're going to go with. I want you to take a look at each of these. Do we decide on 3 or 4? Are these?
So I think this is the one, not that one. Groundwater managers. Yeah.
Groundwater managers we're focusing? This one here?
Yep.
Okay. And can I get rid of this?
Yes.
Okay. So we've got growers, groundwater managers, and oil and gas industry, kind of a wide, diverse set. Those are the key entities, and they're making decisions about futures, about weather, about soil, and crops. We're trying to capture the decisions they're trying to make around those areas. This gets a little tricky. So one decision per Post-it note. Break into your groups. We're going to take a little more time on this one. So probably give you about 10 minutes. Have a discussion first. Capture as many as you can capture here. And then we're going to exercise next. So brainstorm the decisions around these entities and these 4 entities, or stakeholder entities. Right? So the stakeholders, growers, ground water managers, and oil and gas industry. And the nouns around what you want to do the analytics are weather.
Can we change oil and gas to energy sector and projects?
Energy sector. Yes, it's your day, so you get to pick what you want. All right, break into your groups. This good? You okay with this? Okay. All right, break into your groups. Let's go. We'll give you 10 minutes in this one. All good things must come to an end. All right, who's going to start off first? Megan. There we go. All right. No post-it notes? How are we supposed to? Yeah. Okay. So what we're going to do next is we're going to start putting the decisions up on the sheet here around the 3 different stakeholders and around the 4 entities or nouns. But we want to start grouping, as we put them up here to sort of accelerate the process, we're going to group the decisions into common subject areas. So you might have lots of decisions related to soil, for example, taken from the perspective of 3 different stakeholders. So we're going to start looking for groupings of decisions that actually will end up being potentially use cases for us. So as we go through this process, we'll try to group as we go. It won't be perfect, and then once we get them up there, we'll look to bring them all together. Ideally, we'd have somewhere between 8 and 12 different use cases or groupings that come out of this. All right, so who's up first? Okay, don't knock me over rushing up here, I know. Remember, it's a fail-safe environment. There are no wrong answers, all right? All ideas are worthy of consideration. All right, call them out, Jay.
All right, what crop to plant? What kind of farming ones? Type and method of irrigation?
Types, yeah, call them out real loud.
Type and method of irrigation?
So do we want to clarify whether those are grower decisions or?
Not yet.
Growers,
Yeah, we don't need to do that yet. In fact, we may not even need to do that at all. Right now, we're trying to.
Policy, well monitoring and frequency, tillage and residue management, authority to regulate water usage, alternative energy development, conversion of coal-fired power plants, water use projections, capital budgeting, R&D investment.
So R&D investment and capital budgeting from the perspectives of whom?
Energy and growers.
Okay. All right, who's next? That's good. That's good, Jay. Way to start us off. Yay, here we go.
Hopefully I'm not duplicating, but I might.
It's okay, it's okay.
So related to what crop to plant is how many acres, what are my inputs, including fertilizer and labor. Let's see, groundwater management districts, should our policies be coordinated with other districts? How much money do we put into education and outreach? What are our taxes on water or acreage of irrigated land?
Keep going, ignore me.
Let's see, what are our annual irrigating policies related to issuing permits or pumping limits? What incentives do we offer irrigators? Managers, how many easements do we offer? Energy, how much water do we need and is it available? What is energy demand? What are current subsidies for energy policy? And what is our corporate responsibility and how do we handle water conservation?
Great. Excellent, excellent.
Sorry, I haven't converted them all to post-its, but what sort of management practices to incentivize or educate around? How to assess or measure water use? Setting allowable depletion targets? Whether or not to return or how to manage crop residues? Changing hedging strategies based on weather and whatnot, fertilizer decisions, soil moisture monitoring, whether to do it, how, whether to invest in new irrigation technologies, and then basic what to plant.
Okay, excellent, very good. Last but not least.
We have some overlap.
Good.
So water rights transfers or interbasin transfers, if applicable. Time horizon for incentives to be effective. Removing barriers, market entry. Markets are where's futures here. Working with partners to improve soil health. Infrastructure, placement, decision making. Updating water law and policy with current science. Borrowing and financing decisions. Understanding that soil processes take time. Well users group decisions. Biofuel research and production. Tech adoption, when to adopt and use. Somebody said that already. Again, the subsidies and policies, and lobbying, which is applicable to growers and the energy sector both. Forecasting, billing decisions for water or oil. Removing counterproductive incentives for water use efficiency. Using crop info on crop consumptive use to plan for future withdrawals, and setting policies.
Okay. Go ahead.
Energy choice as it impacts sustainability.
You can put it on the next page if you want to, if it doesn't.
Precision ag investment choices. Flexible water policies based on futures with weather and climate. Which energy source to invest in. How much and when on the water. And then labor decisions versus equipment decisions.
Excellent. So here's what we're going to do, the hard part now. Intermixed here were a couple of potential subject areas, right? We had some around incentives, right? We had some I heard around subsidies, weather, alternative energy. So I'm going to have this group here come up, and what I want you to do is I want you to take and start looking for common groups and start putting them into common groups, right? You're gonna decompose some of these, because this is nice. We got some really good stuff here, but some of them we can break it down to a finer level of granularity. And so I'm going to ask this group here, and anybody else who wants to come up and be a part of that process, please come up. But I want to get this. We've got kind of 4 globs. I want to get it to something a little more granular. Okay? At this point in time, based on the decisions. So we're almost all we used these is to help us generate ideas of decisions. And now we're going to take it because what we find is that stakeholders make lots of the same or similar decisions. Sometimes they just have different perspectives. So we want to capture those all together. So we use these different perspectives to help us think more broadly.
So like, give a really good example of this. Whoever put, refuse or residual runoff in contaminated water, that kind of thing, as a decision, could be good, irrespective of who the stakeholder is. Because energy and oil and gas, groundwater disposal is a huge issue. It's the same kind of thing. How do I dispose of or think about what's potentially a contaminant in my water, and how does that impact the aquifer, the soil itself, and how I grow? Those things, that as a decision could be lumped together as a single thing that would apply to any or all of the entities that you defined as a stakeholder.
Yep.
Saying and grouping the decisions, saying these decisions are all real similar to a specific outcome is the real focus, not thinking about the stakeholders themselves.
Exactly. Bingo. Thanks, Brandon. All right, come on up. Anybody else who wants to come up and be part of this process? And once you find certain groupings, call them out. What do you have there?
So irrigation.
Irrigation.
How, when, and what.
Okay, we've got an irrigation category. Here, put it underneath.
Crop plan, what to plant, and then maybe one on sort of the choices of which
So we have one here on what? Crops.
technology adoption.
Tech adoption, okay. Yep. Crops.
Should that one be irrigation then, or should it just be like withdrawal, like groundwater withdrawal?
What one's that? Okay. These are crops? Perfect. Put it right in this little box right here. Thank you. Oops, I got it. But we always stick them on the raw.
Oh, okay.
They stick better. Just kind of a my value add.
Yeah, like pumping decisions.
So say that again?
I was just wondering about the irrigation category, if that should just be like a pumping decision, like groundwater withdrawals, so that it's not specific to.
Right, that's sort of what it's coming towards. Yeah.
So what's further clarification?
Pumping decisions, basically.
Okay, great. Perfect.
This is all almost energy right here.
Yeah, so what are the key things?
There's lots of energy.
There's a lot on sort of the form.
I feel like these are all like a budgeting decision by the groundwater management districts, because how much money are we putting in education, are we using that money as an instead?
Okay.
Are we paying for incentives
Why don't you give me all the budgeting ones then?
by the district?
Budgeting and or incentives, right?
Yeah, okay.
Policy, financial.
Yep, good, good.
Like sort of incentives or taxes.
Yep.
Setting a policy doesn't require money out of their budget necessarily, but still it's a decision.
Is that also part of this? But, oh yes, budgeting, yes, of course, thank you. Yeah.
So what do we have? We have
We have irrigation and pumping, we have tech adoption, we have crop, and we have budgeting slash incentives slash subsidies.
What about the scale?
do we need to move all of these over?
Eventually, they'll need to find a class or they need to stand alone. I mean, ideally,
Budgeting should go in the
excellent, good.
hedging strategy.
So where does the markets type stuff fit in terms of forecasting, hedging, markets,
I
broader
stuck it under
This-
budgeting, maybe we make another category though.
For forecasting,
One of the things sometimes that's helpful too, I find, is with these is if you frame each book sticky around
excellent.
the decision to make is dot dot dot. Some of these aren't framed.
Incentives, yeah, that's a good one. Yep, that goes right there, yep. I'm gonna move these over here because they don't have homes yet. We don't have anything for energy, do we?
They're all left over here.
Okay, well, I'm gonna make you move them all over, because I'm a bad guy. Oops. So energy, why don't you start moving those all over here? Energy impact.
Energy demand.
Yep, I guess that goes there too, good. We don't have anything on policy. Should we create a category on policy? Okay.
Incentives here.
That's incentives, that should go here. Is that policies?
It's a group decision for well use. Here's well permitting policy procedure.
Okay, so let's do it on well permitting. Do you have more than one? Okay,
This should go with that crop category.
got it, thank you. We still don't have anything on policy. Do we, is that all going to be captured here in incentives and budgets?
I think so. I think that ended up being somewhat policy as well.
Okay,
And so water rights transfer maybe? Yeah, that would
is that policy?
Yeah.
It's okay, good.
Do it.
Well users,
Lobbying for subsidies.
we got well users over here. Setting policies.
setting policy.
They're finding homes. We're getting there.
So this is like a kind of a,
Oh, good.
I think this is kind of a crop thing. How many acres do we?
Yeah, yeah. Crop.
That's management, soil.
Soil crop. We're finding homes. That's good.
Where to drill, where to put infrastructure.
Is that pumping?
No, this is also like elevators and,
Uh,
can we just crumple it?
we can have it all other. It's okay. All others can sit by themselves. Don't crumple it. All ideas are.
Where is that? R&D investment, that's
But-
tech, I think.
Oh, okay. Good, good, okay.
Tech. That was the intention was here, like what information?
Yeah, I think that goes there. All right. So so here's what we've got. It's, everybody, here's what we came up with. And but can somebody write a post-it, just a title for each one of these things? So here are the use cases that came up, folks. We have a use case regarding energy impact and all the associated decisions related to that. We have a use case regarding forecasting. We have a big category around budgeting, incentives, and subsidies. We have a category around policy, like policy effectiveness. We have one around irrigation and pumping. We have a category around tech adoption. We have a large category around crop. And finally, a category around wells and permitting. Good. That's a very good job. So we got 1, 2, 3, 4, 5, 6, 7, 8. That's usually we try to look for groupings between 8 and 12. That's kind of the right. If you have more than 12, you probably have a little too granular. If you have less than 8, you've got not enough. So here's what we're going to do next. And this group is going to help us through the process again, but anybody else is welcome to join us, is we're now going to take, if somebody is writing, can somebody write a post-it note for each one of these 8 categories? Because what we're going to do now is the fun part. Single most important management tool we have for driving group alignment is the prioritization process. And we're going to take each of these use cases and we're going to put them on this chart with respect to each other based on the value of that use case. Now, I've left value pretty nebulous, right? It's not, it might be business value, it might be value in our ability to preserve the water, but it's got some sense of a value equation here. And the feasibility is, again, we're trying to target 12, maybe 18 months at most. We want to find things that are quick wins for us, low-hanging fruit. So I'm going to bring you back up here. We're going to take each of these use cases. As somebody, Megan's doing such, thank you. And so what we're going to do is we're going to start off, and what is going to happen is we're going to ask you to defend. If you think that use case 1 is higher than use case 2, you're going to explain why it's more valuable, or why is it more feasible. And feasibility is a tricky one, because there's technical aspects of feasibility. Do we have the right technology, the right data, the right skill sets? There's also organizational policy issues. Can I get people to change? Right? What do I have to do to make that change? All right, got them right there? All right, so let's all come up here to the board. Come on up. This
How are we defining value again?
value can be determined based on both business value. It also is going to include, like, how do we reduce the rapid reduction of water, right? So that would be one. And it's not maybe quantifiable to a dollar, so I didn't put dollar here. But it's certainly for our exercise.
The impact, the relative impact, focusing on that would have
On the water, yeah. All right, come on up. Come on up. Come on up. Don't let me stand up for myself. I'm shy. Okay, Crop management. Very, very feasible. And the value?
I'd say mid-range,
Okay.
meaning there's no silver bullets that are gonna,
Yeah, takes effort and you're
yeah.
not sure.
And you
Okay.
probably have small incremental improvements in a large.
All right, good. So this, we got a place for it, right? Now, it could move, and it might very well move, but what we're saying is it has fairly feasible, but the value is sort of midland. What about forecasting?
Probably high value, but harder to do.
High value?
It was things like ability to change hedging strategies, flexible water policies based on futures, climates.
So is it water forecasting and usage forecasting, or?
With monetary forecasting
I think it was connected to markets.
Okay.
there's a market. So value can be high, but can you do it very well?
Right, so it's something that's probably influenced by broader scale factors that are harder to change, but it might have, yeah.
So the feasibility is going to be low. The value is it high, medium, low? Speak now or forever hold your peace.
I'd say medium high, if we could really change the system, it could be, yeah.
Yeah, okay. I'll put it here for now. Is it more valuable than crop? If you could do it, is it more valuable than crop? Okay, that's the only criteria, right? It's harder to do, but it's more valuable. Okay, we'll come back to these. These won't ever. So energy impact, right? The categories of alternative energy.
What were the decisions? Just reiterate a couple of those.
Yeah, can you call?
I think part of the thinking is that the energy sector is a really important player in water and the economies in these regions. And what are the feedbacks? But yeah, can we, so there's transitions to renewables, there's,
But they're already
Biofuels.
pumping, so they can already do it. So what's the value gain in energy costs us around that with water?
it's costing more. as
So
it-
if you could grow same crops with less water, then energy, there's the value of not spending as much money pumping the water. So
Right.
there's some value in pumping
Right,
water.
or if you can't pump at all, then the energy sector is gonna hurt.
Yes, yeah, there would be
Yeah.
impact. But I don't think, would it
I'm
really
kinda-
transform the whole world out there?
Most of the energy is exported out of the region.
Yeah.
Like if you get to the gas
So it's a
fields,
surplus.
all that energy goes to Chicago,
Oh, okay.
so it's not gonna impact.
So maybe not,
I'm thinking low and low.
Might be a low impact.
Low, that's interesting. Low feasibility, low value. Energy.
Well, I don't know, it depends what we're talking about, because when I think about energy, I'm thinking about how solar and wind are becoming big-time businesses for stacking economies. As the water's drying up, people are still able to use that ag land for ranching and at the same time stack another economic value that they can derive by leasing wind rates.
Yeah. Like a farmer who can put a wind turbine on their farm.
Yeah, it's sort of replacing some of the water value.
So the value is increasing.
The value is increasing over.
And the feasibility is still low?
No, that's not that hard, that's,
I'll put it middle here. Let's put it here for now. Policy.
Low feasibility, very high impact.
It's our category F. We always call this category F. Yeah, this is the one that you can change the world, but it's not short term. Well permitting. Well permitting.
yeah, how much could we improve it beyond where it is now? It'd be relatively,
Low value, you're saying?
I'd
The
say in terms
incremental?
of improving from where we are now,
Yeah.
you probably can't
more wells isn't gonna change.
that much more than is already restricted. Yeah, there's some exceptions.
All right, so it's low value
Yeah, I'd say pretty low.
and feasibility. Probably high. Medium? Yeah, it's easy to do, but it's not worth doing.
Yeah.
All right, it's one of those categories. Easy to do, but not worth doing.
Do it, but they're not really doing it very good.
What about tech adoption?
Feasible
And the feasibility? Huh?
Easier than policy?
Yeah. Everything's easier in policy. All right, let's jump. Irrigation and pumping.
I mean, that's high return. It's very high return.
And the feasibility?
We change producer behavior without changing policy and methods.
If there's timing of information, it's in their own benefit, they would do it. You'd have to show it and communicate it.
So is it high value? Would we agree high value?
High value.
Mid-range maybe, as far as changing their behavior.
So we're taking all these things about.
Yeah.
Irrigation pumping and how they do it, water usage.
So just on quick, let's focus on these three for particular, right? So we've got three items that fell into the higher value, higher feasibility area, right? Crop, we have tech adoption and irrigation pumping. 1, 2, 3, 4, 5, 6, 7. Yes, we're missing, oh, and incentives. That's actually probably a pretty good one. Good catch.
Where are the 8? Where's the 8?
That,
I'd say these are somewhere nearing policy.
as far as value, feasibility, hard to do.
But easier than policy maybe.
All right, so maybe slide over here a little bit. But not into, this is our sweet zone here. Right, and these are the things that fall in here are the things we really want to go after. And so we think we have three areas. Again, this is pretty quick, hour session or so. But we think we have three areas we'd want to drill down in more detail. We want to understand more around the decisions around that we're making around irrigation and pumping across our stakeholders. We'd want to understand more about tech adoption, in particular get more focused as far as what kinds of tech adoption, almost done, and tick, and crop management. So those three are the candidates that come out of this process. We don't want to throw these away, obviously, because we may find in further investigation that some of these things start moving over. What typically happens, by the way, folks, I can bring you all in real quick. So here's what we came up with. We came up with three areas that are close to the sweet spot of high value, high feasibility. They're kind of skirting the edge of it. The high value ones that were sort of mid feasibility were irrigation and pumping and tech adoption. And the one that was higher feasibility but lower sort of mid-range value was around crop management. Now, what we'd want to do is we'd want to drill into more detail on those, maybe if anything else was nearby. But these are the ones that are kind of our initial candidates we'd go after in order to try to target our water optimization usage. So we don't lose these ones here. For example, budgeting incentives and subsidies was seen as being really, really high, but really low feasibility, or medium low feasibility. And so what happens is if you start targeting these things and you start delivering success here, these things start marching over. They start becoming more feasible. They start becoming more feasible from a technology perspective, from an analytics perspective, and even from an organizational or policy adoption political perspective. So you keep this, you probably do these first three, and then you revisit this chart to say, okay, have these things moved over? Have we been able to influence people by the success we're having here? We're not going to go into the process now. What we want to do is we want to brainstorm some of the data sources here. But that's, I'm tired, you're tired, you put your work in. So you want to wrap it up? I'm kind of just hanging on here for dear life. Nice, by the way, excellent job. That's how the process works, right? We went through a bunch of different perspectives. We thought about our stakeholders, our nouns. We brainstormed decisions, and we grouped the decisions into use cases and prioritize them. So now you've got a pretty good idea of where to start this process.
So for those of you who remain, thank you. You've contributed greatly to these ideas. Megan, I hope it's helped you out. It was great. I got an email from CSU System. We had about 25 faculty down there who were part of this. This has been recorded, so if you want to go back and review it or use it for anything, it's going to be, I've got a link for the recording. But please, everybody give Bill a hand.
Thank you.
And Bill, if you'd come up, we've got a special little something for you as a thank you.
I like gifts. Oh, wow, that's great. Thank you. It'll go in my man cave.
Yes, there you go. Something to remember CSU by.
Yeah, thank you very much. Great. This was a great session. The presentation was wonderful. I appreciate the very creative brainstorming, and
Well, we hope to use these ideas.
let's save the world, okay? Just one use case at a time.
All right, thank you very much.
I will make the presentation available, so I will send that to you and make it available. We
I'll
publish
send
it.
it out to everybody who's on the list. All right? Nothing else? Again, thank you
Thank
very
you.
much.
Thanks, man.
All right.
Great. Thanks, everybody.
I'll go ahead and put this in the box.
Oh, that'd be great. Yeah, thanks.